Hey everyone, welcome back to my channel. It's good to have you here. So as you can see, I'm in a very different setting right now. So pretty sure everybody who's been watching my vlogs knows who this is, but in case this is your first time watching this vlog, this is my best friend Gus.
Hello.
And for those of you who don't know, Gus is actually a chemist, so that makes him a scientist, so that makes him really cool and much more amazing than me. We decided to we were thinking about creating a segment back when I was kind of starting my channel, and one of the segments that I told Gus about was I want to do like a science thing with you, and so we never really got around to it. And so he hit me up earlier and he said, hey, I've got some really cool stuff that I like to do for that science segment that you said you wanted to do on your channel. So I was like, okay, cool. So we didn't know what to name this segment, so we're gonna call it Science with Gus. Ta-da! Yay! So Gus is going to show us this really cool science experiment. I have no idea what Gus is going to show us, but we're going to see some really awesome and cool stuff, because anytime that anytime that we get to see some awesome science stuff, it's awesome. I used the word awesome twice, but yes, that's what I mean with science. So Gus, what are you going to show us?
So as you can see, we have some smoking stuff here. It is called dry ice. Cool thing about dry ice is it's a solid at room temperature. Well, it comes from CO2, same thing that makes sodas fizzy, right? That's actually what makes the soda fizzy. Cool thing is when it gets solid form at room temperature, it's not wet, it is really cold. And the cool thing is it sublimes, means it doesn't go from a solid to liquid and then gas. It goes straight from solid to gas. So that's what you're seeing here is the CO2 gas. It's denser than air, or denser than the surrounding air. That's why you see it kind of fall and it doesn't rise.
Okay.
But yeah, we could perform some cool things with this. It's really cool.
I don't know if you guys can see it, probably not with this main camera, but maybe with like we have a side slow motion camera, but it's not crystallizing, but what is it doing here, Gus? See it, Gus said, right, it doesn't liquefy, it goes from a solid to a gas. So there's no water like you would see with regular ice here, right?
Right, so on the actual solid, but it does form ice. So that's what this white stuff here is actually water from the air that has cooled down to freezing point and formed a little white solid. As you can see, you touch it here and then when you put it on your finger it gets wet. So that's actually water condensed or frozen down into ice. So yes, this is colder than ice. And it's a cooler way to freeze your things and keep your things cold better than ice. Because ice, you get water in your things. This one, you just pack it in, it's cooler, and all you get is just the gas discharge.
And also, I think, and correct me if I'm wrong, Gus, but if you can't afford a fog machine, but you want to use fog for something, whether that be for a project or for Halloween time, you can actually buy dry ice.
Yes.
And just, do you have to put it in liquid?
It's in order probably better to be put in liquid. I'll show you some cool things with that. But yeah, you just need to play around with it and optimize your setting. But yeah, actually I just saw a YouTube video. It's called a Chauvet, I think that's how you pronounce it, ice fog machine. So they actually do use dry ice to make dense, thick fog. So I think they'll use the dry ice in combination with the fog solution to make like a thick layer of fog. So
there's an idea. But of course, remember, if you are a minor, probably actually if you're not even like in high school, you probably want to get an adult to help you with any kind of experimenting that you are doing with dry ice, right, Gus?
That is correct.
Cool.
I was gonna say science is fun when you do it the correct way under correct supervision. Fair warning, I do not have gloves on right now.
But Gus is a professional, so he can do that.
Yeah, so I know how to handle this without gloves, but if you are going to use this, not just not any regular gloves, you want to make sure it's like oven gloves or something that's insulated, so you do not burn yourself. Not like fire burn, but like this will cause like freezer burn on your skin. So, and it does hurt.
Cool. Well, let's get into the science, the awesome experimenting stuff that Gus is going to show us.
Cool.
So, what are we doing first, Gus?
First, I'm going to show you what it does with just in a regular water bottle.
Okay.
I'll bring out my stuff here. I'll bring some more out here. you can see, you just put a little pellet like this. So I'm gonna put it in here. I'm gonna put a couple more in here. And you can see it fogs up pretty nicely. The hotter the temperature of this water, the more it'll fog up. The reason being the temperature difference from the ice to the warm water. It'll cause more vapor.
Awesome.
So this is pretty cool. I mean, since it is denser than the air, yeah, you can scoop it. We're outside, so it's not really that
So can you guys see
friendly. So you can see, I'm not pouring any liquid. It's just all pure vapor. Or you can pour it onto Raphael's hand. The wind is not helping right now, but that's pretty cool.
That is so cool. Here, let me see that.
Yeah.
I'm gonna bring this up close to you guys, like right there. Check that out. Check that out. Whoa. Pretty dense.
Alright, the other cool thing is, since this is a gas being discharged, right? When it's nice and open, the water bottle is like this, it'll be, the gas just vents. Put your finger in, and you will start to feel pressure.
Oh.
So you could create a cool little stream of just carbon dioxide. Let's try to get this guy.
Now, is that making your finger really cold?
No, you could try it. So the ice is really cold, but the gas kind of feels cold, but it's not that cold. It like comes back to room temperature. If you feel anything cold, it's because the water is like cooling your hand down.
Yeah.
But that's it.
Yeah, I don't definitely feel it while it's in there, but like you feel it whatever it's coming out.
Yeah.
Or trying to come out.
Yeah.
It's really cool.
So that's pretty cool. As you can see here, I have a candle lit.
Yeah, what's with the candle and the fire?
So whenever you have any candle, any fire, right, you need a fuel, you need oxygen to burn, right? CO2, most extinguishers, fire extinguishers, are carbon dioxide based.
Okay.
So what you're gonna do is, like the white foam has a lot of CO2 in it. So you spray it and it kills the fire because it removes the oxygen from it.
Okay.
So that's exactly what I'm gonna show you here. So there is water in here, but I'm going to fill it up a little bit more. Trying to get more of this gas to go. And I'm going to extinguish this candle here without touching it, just pure CO2 gas.
Okay.
Ready? I'm gonna wait for the wind to die down because it's blowing in the wrong direction.
Definitely harder to do gas experiments out in the open.
Yeah.
Alright, I think it feels kind of down.
Yeah. Ready?
Try.
There you go.
Should I bring it up?
Yeah, you're gonna need to shield the wind. Let's make sure it's in that camera right here. Okay. Yeah, right there.
There we go.
So, are you ready?
Okay. Whoa. That was so cool. Can we, okay, watch this back.
Here. Okay, the other cool thing you can do with this, we could do it with this one, this is pretty cool.
Okay.
You get some dishwasher soap, some dishwasher soap in here with just some water.
Okay.
You just see it in here. I'm trying to put it in this camera right here, but this one will be fine. And then you just lightly pass it over.
Whoa.
You gotta burn the wind.
Are you guys seeing that?
Let's try this one more time. I'm gonna try to do it on this big glass.
That's so awesome.
You're making me worse. Another cool thing you can do with it, since it goes straight from solid to gas, you can make things vibrate and you can make weird sounds with this. So I have a quarter here. You just put it right on. I'm pretty sure you guys can hear that. It can make like a screaming sound.
So why did you do that?
So what happens is the metal is hot and it's contacting the solid.
Okay.
It's forming like a gaseous layer so from solid CO2 to gas CO2, and so it's vibrating. I'm pushing down on it,
Awesome.
or the weight of the own metal will contact it. It'll produce gas and come up, and it'll vibrate so fast that you can hear it.
That is so cool.
That's pretty cool.
I want to try that.
Yeah.
Whoa,
was
can you
pretty
guys hear that? There's a high pitch there. You know, one of my favorite things to do back when I was taking science classes in school was literally the lab portions. So you got to do really awesome experiments, and Gus gets to do that kind of thing for a living. That's really amazing.
Sorry, I just went to go pour some water out. It's too much.
Okay, now I feel like we're in a mad scientist lab. We just need like the other awesome colors.
Like, this is
things
really
to,
cool because
light
like
up.
you can like gather it in your hand, and it'll just stay in your hand. That's how dense it is.
Wow.
And then you can just. The wind is not helping out, but
So, you know how we were saying that if you wanted to do, if you needed fog for like a project or for a nice Halloween effect,
yeah, I'm gonna try this bubble.
that's what you do. It's really
I'm
cool.
gonna try to make a bigger bubble. Ready?
Oh my gosh. Whoa!
I got soap in there, so it's gonna do that.
That's crazy.
Yep.
That's really awesome.
Cool thing is, you can probably get this. I'm gonna dump this over the fire. Let me get enough. Let's see if I can dump this over the fire. Yeah, come on.
There's just so much bubble in there. Poof.
It's out.
This looks like carbonated water now.
Well, technically it is.
Like soda.
It has a funky taste, but yeah, that's basically what it is.
Soda?
Yep.
There you go.
So if you feel this, it's cold now.
Oh
Started at
wow.
room temperature.
This is really cold. And the bits of the dry ice that's left in there is still bubbling up in there. That's really cool. Hey, well, thanks for showing us these really awesome stuff with dry ice, Gus.
You're welcome.
So, if you guys enjoyed the video, please don't forget to give it a like, subscribe, and comment down below. Have you seen these kinds of experiments before, or have you ever experimented with dry ice? Remember that if you ever want to try any of these experiments and you're still a kid, make sure you have adult supervision and have their help when you're trying these cool experiments out. Thank you guys for watching. We'll catch you guys in the next video. And until then, see you then.
That wasn't fun.
Cheers, mate.